All right, guys, this is the video explaining homework number 1. So that was problems or exercises A1.1 and A1.2. I'll make a separate video for the graduate problems. So let's start with A1.1. So it tells us, it defines a couple of different sets for us. It defines the set A as the set of all even integers. So I'm going to go ahead and write that in set notation. So it's all x's that are an element of the set of integers, z, such that x equals 2 times m, where m is an element of the set of integers. Right? So any integer you pick for m, you plug it in here and you'll get an even number for x. B is the set of all odd integers. So it's the elements of the set of integers such that x does not equal 2 times m for m, an element of the set of integers. Right? So you pick any m that's in the set of integers, you plug it in here, and it's going to basically exclude all of the even numbers, right? Any number that's not equal to 2m, right? But is still an integer. Then we have C, which the simple way, I guess, to describe set C is to just write out all of the numbers, or rather all of the integers between 1 and 10, or from 1 to 10. So we could write it like this. Getting a little long there, so we might want a better way to describe that. So we could also describe it as, or define it as, the set of x's that are elements of the set of integers, such that x is less than or equal to 1. I'm sorry, greater than or equal to 1, and less than or equal to 10. Okay, so that's all of the integers that fall in that range, just like that. And then the last set is D, which is simply the set of non-negative real numbers. So you could simply describe it like that. Or if we want to be a little bit more clear about what that is, we could say that x is a set, or x rather is an element of the set of real numbers. So either R or R1, doesn't really matter which one, such that x is not negative. In fact, that would be an equality there, greater than or equal to 0, right? Okay, so the first set we're asked to describe is the set C union A. And there's a couple different ways we could describe this. The first way I'm going to do is, it's the set of x's that are elements of the set of integers, such that x equals 2m for m, an element of the set of integers, or x equals 1, 3, 5, 7, or 9. All right, so that's probably the best way to describe it. Or you could just use the definition of union, right? And we could say that it's the set of x's that are elements of the set of integers, such that x is an element of C, or x is an element of A. All right, so that's just using the definition of what union is. All right, the next one is C union B. So it's going to be pretty similar. So we could describe it as the set of x's that are elements of the set of integers, such that x does not equal 2 times m for m, an element of the set of integers, or x equals 2, 4, 6, 8, or 10. Right, so basically every odd integer or this set of even integers that are between 0 and 10, right? Because C includes 1, 3, 5, 7, 9, which are already part of this set here, right? Those are odd integers, so we don't need to. We've already got those covered, and then we just need to add these in as well. So the set of odd integers or one of these even integers. And again, you could also just simply use the definition of union, X an element of Z, such that X is an element of C or X is an element of B. All right, the next one is C minus B. Right, so everything that's in C excluding what's in B. And this is actually the same as C intersect A. I'm sorry, is that right? Yes. C intersect A. Right, because C is, again, the set of the integers from 1 to 10. So we're taking that set and subtracting from it all odd integers, which would be the same as the set of integers 1 through 10 that are also part of A, the set of odd integers. So that's just another way to describe it, right? So the way that we can do that is we can do simply the set of x's that are elements of the set of integers such that x equals 2m for m, an element of the set of integers, and x is greater than 0 and less than or equal to 10. Okay? So we can do it that way, or we can just use the definition of minus, the operation minus. So this is also defined as a set of x's that are elements of the set of integers such that x is an element of C and x is not an element of B. That'd be another way to describe it. All right, the next one is the operation A intersect D. Right, so everything that's in A and D. So anything that's in both of those. And since D is just the set of positive integers, we're looking for basically positive even integers, right? This is going to describe positive even integers. So one way we could describe it is the set of x's that are elements of the set of integers such that x equals 2m for m, an element of the set of integers, and x is greater than 0, right? So ensuring that it's positive. So even integers that are positive. There we go. And again, we could simply also just describe this using the definition of intersect. So x, an element of the set of integers such that x is an element of A and x is also an element of D. All right, the next operation is B union D. So everything that's in B or D, so anything that's a odd integer or a positive real number, or rather actually a non-negative real number. So I'm just going to describe it this way. there's probably other ways to describe it, but x such that, okay, we don't want to limit x to just integers anymore because the set D is all non-negative real numbers, not just integers. So just x by itself such that x is an element of B or x is an element of D, right? Again, just using the definition of union. So that's definitely the easiest way to do it that I can think of. Again, there's probably other ways to describe it, but that's definitely the easiest. All right, the next one is the set A union B. So all of the numbers that are either positive, even integers, either even integers or odd integers. So this is actually just the set of all integers. So that's pretty straightforward. Nothing too hard there. And the last one is A intersect B. So any number that's not an even number and not an odd number. So this one is basically going to be the null set, right? Any, right? Because this requires that it's in both, but these two sets have nothing in common, right? So there won't be anything in this set. So it's just the null set. All right, so that's A1.1. The next one, A1.2, exercise A1.2, is asking about greatest lower bound and lowest upper bound of several different sets. Okay, so the first set is the set of natural numbers. So this is the counting numbers, 1, 2, 3, etc. 0 is not included, of course. So the lowest, the greatest lower bound is just going to be 1, right? So I'll go ahead and write the set out here just so we can see it. 1, 2, 3, ... right? So that's the set of counting numbers. So there is a lower bound here. There's several lower bounds. I mean, 0 is a lower bound, 0.5 is a lower bound, but the greatest lower bound is just 1. Okay. And as you can see, this set continues on forever. So there's actually no upper bound here. And since there's no upper bound, we have no least upper bound. There we go. I'll just put that. Okay, the next one is an interesting set of quotients or ratios. 1 over 1, 1 over 2, 1 over 3, ... 1 over n. Okay, so these numbers are getting smaller, right? And as n continues to grow, the numbers are just going to get closer and closer to 0. So we do have a lower bound. The lower bound is 0. And in fact, that's the greatest lower bound. We also have an upper bound. The biggest number here is just 1. And so the least upper bound is just 1. So just interesting to note, this greatest lower bound, 0, is not part of this set. 0 will never be a part of this set. But the lowest upper bound or the least upper bound is part of the set. So just take note of that. Okay. The next one, C, is an interesting series of numbers as well. 1/2, -1/2, 2/3, -2/3, 3/4, and so on. All right, so as we go in this direction, we get closer and closer to 1, right? Basically one term is n minus 1 over n for any integer n. and the other numbers are just the negative versions of those, right? So as n gets bigger and bigger and bigger, this thing gets closer and closer to 1, and so that gives us our greatest lower bound will be -1, and our least upper bound is +1. Okay, the next one is the set of x's that are elements of the real numbers such that x is greater than 0 and less than 1. So this is pretty easy. Here's our greatest lower bound and our least upper bound here. Of course, they're not parts of the set because there aren't equalities as part of these inequalities. So the greatest lower bound is 0 and the least upper bound is 1. And in fact, that's the same answer for E and F as well. So for E, x is an element of the set of real numbers such that x is greater than or equal to 0 and strictly less than 1. And so again, we have the same greatest lower bound and least upper bound, only this time this one is a part of this set where it wasn't a part of this set. And the least upper bound is still not a part of this set, just like here. Okay, so same answer for E. And F, almost no difference in terms of the set, except for that this time 1 is included because we have an equality here. So again, same greatest lower bound and least upper bound, only this time 1 is a part of this set. Okay, so if you guys have any questions about any of those, feel free to reach out to me and I'll help you out.